Right. After Aidan spent all his time slagging. No. Right. So let's talk. Okay. With probability, it might help if I could actually spell. Replacement versus non-replacement questions. Okay, that's what we're talking about doing. And we're going to carry on with our use of tree diagrams, or that method that without the tree diagrams, but the multiplying and adding of the probabilities. So you already know that the probability of A and B happening is found by doing probability of A times the probability of B. And you know that the probability of A or B happening is A plus B. There are other things to consider, like that's not everything, but that's what we're looking at, all right? So what we're talking about is what happens when the second outcome, the probability of that is affected by what came before. Okay. So let's talk of a situation like you have a bag of counters. All right. This is a normal kind of situation. So let's say a bag of counters of different colours. So what colours should we have?
Blue.
Let's do blue for the European champions. Purple. Orange. Green. Let's do with that. How many blue counters are in the bag? 3. How many purple?
1.
How many orange? Why don't I put a separate? How many did you want? 2. You're so demanding, stuff. You're just dictating everything. And 7. Green? 7. Okay. Right. So, what would be the probability, okay, of getting a blue counter? If you put your hand in the bag, it's completely ready, look, and they all exactly the same. Yeah.
So you have a 3 in 20 chance of getting
3 in 20. Are you happy that all of these add up to 20? Yeah, you pick some nice numbers. All right. The probability of getting an orange is
2 in 20. Or 1
2
in
from
10.
20. We're not going to simplify. Okay. That's all good for everyone, yeah? Okay. Now, if I then said to you, what's the probability if I take 2 counters from the bag, what's the probability that I get 2 of the same colour? He hasn't, has he? Go on then.
So to get 2 blues in a row, it's a 3 in 400. 3 in 400.
Nope.
Are you asking for any, like, a general statement?
So, what's the probability that I get 2 of the same colour? So that could be, all right. So let's look at the options. We are saying probability of blue and blue. The probability of purple and purple. The probability of orange and orange. And the probability of green and green. And the word going between them is or. Yes? So there's a good question, isn't it? What did I say? I said pick out 2 counters. How do you do that?
By grabbing 2 counters.
You can go 1, 2,
I said 1, then another one. Okay, so by saying you take 2 counters, you would probably go and grab, if you could, just 2 counters if you could feel it. Yeah? is that a replacement or a non-replacement situation?
Non-replacement.
Non-replacement. Is it the same or different than picking one out, looking at it, putting it to the side, and then picking out another one?
Different, because that way.
Is it the same or different? Yes.
Different.
It's- it-
Different than.
It's the same. It's the same. It's the same.
Okay. So mathematically and actually physically, it's pretty much the same thing, isn't it? There's less movement. So in this case, this is a non-replacement question because I would have to have specified you take a counter twice. So you take one, you look at it, and you put it back in. All right. So that impacts things, doesn't it? So if we were to say, in this case, like take two counters, we're actually then saying it's a non-replacement question, right? Without saying it's a non-replacement question. You have to know that that's what you do. So how do we work this out then? Well, you might choose not to bother, but let's do a tree diagram. So we can do blue, purple, orange, and green. So I've got all the branches that side, okay? What are the probabilities? Well, we've already been working at that. So blue is 3 from 20. Purple is 8 from 20. Green was 7 from 20. So what was orange? 2 from 20. Okay. Now, I could extend my tree diagram by drawing all of them again, but I'm not interested in that, am I? So all I actually need to do is do one more branch to another blue, another purple, another orange, another green. That's all I'm interested in. Right? There are other branches, but I don't need to consider them. What I do need to consider is what is the probability of getting a blue this time? Yep. 2 out of 19. Why? I can see Cameron in the corner. Do you know what? Go for it.
Plus the 3 represents the number of blues, so if it's the correct one, it's 2, and 20 represents the total, and if we have blue, it's also the total.
Exactly, it's that non-replacement thing. There are now less blues because I took a blue. Yeah? And because I took a blue, there are less blues and less counters in total. Right? So the next one, if I'd taken a purple, the next chance of getting a purple would be? Yeah, I keep doing it myself. Right. 7 from 19. Then it would be 1 from 19. Then it would be 6 from 19. Okay. So the probability of blue and blue would be 3/20 multiplied by 2/19.
6, 380.
Yeah.
So it's 6, 380. 56, 380.
So 2/20 multiplied by 119
So 1,
is
3.
and then 7/20 plus 6/19 is
42.
all right.
106, 380 is the chance of getting a few of the same.
Add those. What are you saying? 10.
106 over 3.
Okay. So that's covered using a tree diagram, that's covered a non-replacement question. If it was a replacement question, these would just stay the same, right? Okay. One then thing to look at is the next question could be, well, could you come up with a question I could use where I could use that answer? So I've got the probability of both the same.
What's the probability of neither being the same? Like not being the same?
So the probability of getting them different colours.
Yeah.
What would be the probability of it being different colours?
274 over 380.
How do you work that?
Subtract 106 from 380.
Okay, so we want to do 1 minus 106 over 380. Okay. Which would be,
274.
just to check, why the 1 minus bit? Right. Yeah, why 1 minus? So this is the answer to that. Why 1 minus that? I'm just checking that you're not just writing down what I'm doing, you are thinking about. Do you know? Yeah. Yeah. So have I covered everything? What you're saying? 2 colours the same or different colours? Is there any other option that I could consider? It's basically 2 the same or not 2 the same. All right? But not 2 the same in a different way, vocabulary wise, is 2 different. Yeah? So different colours. All right? There are no other options. So that's what I would consider. All right. So, there's not an awful lot to it. It's just you have to adjust based on what happened before, what you have options for the next event, right? So let's just have a quick talk about when could I have a situation where it's a non-replacement question but it's not obvious. Any ideas? There's a lot of questions will say, a counter is picked and not replaced. A counter is picked and is replaced. So we've got to think of a different situation. Maybe not obvious. Any ideas?
The example you give for pick 2 counters isn't the most obvious thing. Instead of saying this is not replaced.
Yeah, just you take 2 counters.
Yeah, because it's not saying it individually either. It's just saying take 2.
Yeah.
So it's,
Exactly. Right? You going off for a second? Yes. So if it was, how would that change this problem if I did put it back in? Exactly. This would still be 3/20ths, this would still be 8/20ths, and so on. Right? Everything else would be the same, yeah? Question though, would it be more or less likely to get 2 the same colour if I did put them back in? Sure?
Actually, no, because if you put it back in, it would be again for the blue example.
So let's just have a look. It would be
392.
9.
400.
This would be 64. This would be 400s. And this would be.
I think it is more likely because it's increasing the numerator by a higher percentage of itself than the
Okay.
denominator.
So if I add those together, what do I get?
A larger number. Come on, all the way up there. My skill there.
Oh, come on.
Wait, I got it.
You got this, Liam.
49 and 4 is 53.
3.
117. 126. Yeah.
It makes sense.
100 and something. Yeah.
Yeah.
That's good enough. We just got 100
But
and
wait,
something.
It makes sense
Actually,
that it's
no.
plus 20 because
Yeah,
it's
because
adding.
it's plus 20 on both.
Well, no, it's adding
So it's the same.
1 over.
Ooh. Someone's just said it's the
It's
same.
not the same. It is very good.
Let me just point something out there. If I have 1/7 and I add 2 to the top and the bottom, they
No, it's
become
not.
3/9. It's not the same. So you have seen that, yes, it's 20 onto each, but that does not, that means it's a different fraction. So if I had to compare those 2 fractions, I could ask my M1s this at the moment because they're doing it.
Simplify the
How'd you
fraction.
do it?
You could simplify the
Good.
fraction since they're 400 divided by 20 would be 10. Well, no, it wouldn't be 10. It would be 20.
Can you do that to the numerator as well?
No, you
Try.
can't do it. You can try.
Yeah.
You can turn them into decimals.
400
You could
times
turn it into decimals. It's like your brother would love to do that. He wants to do that all the
I mean,
time.
you can.
400
We can do
times
that.
380.
Pardon?
400 times 380.
Yeah, okay, you could do that.
You could do that, yeah. You,
Yes, you could get big numbers, but it's not a problem. If I'm literally asking which one's bigger, there's a couple of options. And I'm not asking you to add them or anything. Niall, what were you going to say? Well, yes, you could subtract, but how do you subtract fractions? So if we've done that, we don't need to subtract. We just want to know which one's bigger. So a common denominator, there might be a lowest common multiple that is not those two multiplied together. Maybe we can divide down, but you know, maybe we could at least go to what 53 over 190, and then 63 over, and then you could, instead of multiplying those, we could just multiply those. So what do you then get? So multiply by 200 and multiply by 190, and you get, I don't actually care what the denominator is.
3 times 200
Yeah,
is 10,600.
Yeah, 10,600.
63 times 190 is 11,900.
11,970. So I don't care about the denominator, I know they're the same, so I'm only interested in the numerator. So this is the larger one. So by leaving one out, so remember this was the non-replacement, this was the replacement. So by taking 2, I actually reduce the chance of taking 2 the same. Yeah. Right.
We could have shown that a bit easier by figuring out between our new probability without it even out and comparing it to, so just comparing the 219 to the 320.
Yeah, that's what I was saying originally, a higher percent of the.
Yes, well that's another number sense way of doing it. The impact on the numerator is bigger than the impact on the denominator. Okay. All right, so that's a couple of things. So that's your non-replacement versus replacement, what happens to probability, and the use the answer to answer another question is often what comes up in these things. So you can do that. So we were talking about other possibilities. So for instance, there are times when if I said to you, I am going to select 2 people from this class to come and help me eat all the donuts downstairs, what's the probability that I get 2 boys?
Nope.
Well,
Because I would pick a boy to help me, but I don't say no. But my situation is I'm picking someone to come with me. So once I've picked someone, I go, Cameron, you can come right now. Go sit back down. Now I'm going to pick someone else. Oh, I've picked Cameron again. So it's just Cameron and I to eat all the donuts. No, so it doesn't. That's a situation, especially when you're picking people to go and do something. For instance, a problem like that. That's definitely a non-replacement. You don't replace that person. Picking. What's the chance of getting a boy and a girl together on the softball team type of thing? All right. Can you think of anything else that would be a non-replacement question that is not specifically
You get a
stated?
randomly colored donut, and then someone else gets a randomly colored donut. What's the probability that people get orange colored ones? Something like that, because the donut would be even, but it doesn't specifically say.
Yeah. So if you went to a shop and someone was asked to choose a donut, and then the next person, what's the chance that they pick the same thing?
Anything that has to do with
There would be a lot of things to talk about in choosing your donut, though.
Yeah.
Unless you pick a random donut
You
with
just
your
say
eyes
surprise.
closed, because
You
people
say
don't do
surprise
that,
me.
do they? There's no randomness to picking a donut.
Like you pick your
Right.
donut, then put it back.
Yeah. Well, actually, that's an interesting one because what's the probability we pick the same thing? If it's from a menu, they're just
Because then
yeah, it's like replacement. Even though you keep your food, all right, they just make another one. They replace it for you. You keep it, but actually that would be a replacement problem. That does bring me up to
You
another
can't
question
really get
about
probabilities.
the batteries actually. Yeah.
Drawing raffle prizes. If
Yeah.
somebody wins something, their ticket would be taken out, and so for the next prizes
Yeah, the chance of you winning
would
is
be
less.
decreased.
improved.
Well,
If you're the person with the ticket, then if you
Have
have
you
one
already
ticket
tried?
in there.
If you already won, you don't need to worry about the probability.
I think
Let me ask you this. There is a question that I've done, so I think it's a DP question though, same sort of idea, where you're in a factory, okay, and the factory is producing batteries. You had the question about batteries, not me.
If
Yes,
a
no, it's about
factory,
faulty
they know what
batteries,
you
or you can have faulty light bulbs or anything. All right. If I'm doing a check, so in factories, what happens is you take a sample out and you do a check every 10 minutes or so. And if you find a faulty one, then you might have to stop the run, and or you find too many faulty, you stop it and then do a bigger check. If it's within tolerances, you're all right. But let's say I'm producing thousands and thousands of batteries, and then I have a vat of batteries, and I take one out, and I check the probability, and then I take a second one, and check if that's also fault. What's the probability of having two faulty batteries? Is that replacement or non-replacement?
Maybe non-replacement because you're taking the batteries out.
It's actually replacement.
Well, you're fully utilizing the battery to test it.
Yes, but we're in a factory running situation where it's a constant flow of batteries. It's not like having, I said a vat of batteries, but it's not like I take all of the batteries, take one, and then put them all back. I don't do that. I've got a conveyor belt of batteries just being made. Yeah, you can say, basically from historical data, we can say the probability of getting a faulty battery is 1 every 10,000. Yeah. So if I take a battery and I check it, and then I take a second battery and check it, the probability of it being faulty, well, if it's 1 in 10,000, I don't make 10,000 batteries, I make millions of batteries. So that's a probability based on historical data. And we're in a conveyor belt. So although I've taken a battery and I found it's faulty, you don't put it back in, do you? You get rid of the battery and you take another one if that's, but the probability of in that situation, it is a replacement one, because you don't consider the first battery to have affected the probability of the second one. Does that make sense? I don't know whether at the level you're currently working at the standard, whether that type of thing is going to come in. But be careful with some of the questions in this section about whether it's truly a replacement or non-replacement, and sometimes it does not specify. So what you're looking at now, okay, so I think this is the section, isn't it? There you go. I think it's this section, example 4. You can see the probabilities are changing. Example 3, box of red pens, whatever. Pick a random pen, probability is changing. So your task now is practice 4 on page 147. This is good. A bag contains 3 red peppers and 4 green peppers. You take a pepper and eat it. You then take another pepper. So it doesn't say you eat it and don't replace it. It just says you eat it.
You eat it, and then you're already